So let's get started. We are honored to have Takao Asami-san, Senior Vice President of Research and Advanced Engineering at Nissan Motor Company, joining us as our first fireside chat guest speaker. Our conversation today will center around digital transformation and digital technology that influence the mobility evolution of what is going through in the world. How electrical vehicles, autonomously driven vehicles, and other transportation innovations are changing the way we live. And as usual, at the end of the conversation, Asami-san and I will invite all of you, including global audience through the online attendance, to submit questions and your thoughts about anything we would have discussed. Konnichiwa, Asami-san.
Konnichiwa, Nicola. Thank you for inviting me as a guest speaker to this renowned event of TDK Ventures. I'm thrilled to explore possibility of future mobility with you and the audience today.
Thank you very much. So let's start with a realization that the last 3 years have been very different. With COVID, the lives of many people has changed. And even working from home is becoming more and more common. How do you see that as the impact on mobility?
Mm-hmm. Of course, we have observed the change from before COVID to after COVID. And at first, we didn't realize that we have such a big reduction in mobility. This graph shows the mobility compared to the timing of January 2020. As you can see, right after COVID started, there's a sharp decrease in mobility, up to 80%, almost lockdown in every city. And it came back to a 0% level. But gradually, the mobility is coming back. Probably by now, mobility is getting much closer to 0%. But still, I believe that mobility will not get back to the original state before COVID-19. That's my observation. Maybe we can go to next slide. Then, how the COVID-19 impacted, what type of mobility? Mobility could be categorized by objectives like employment or work, go to work. Study means to go to school. Shopping of grocery and other things, and leisure for entertainment, restaurant, and meet people, and sightseeing. And as you can see, when it comes to people flow, we got 20% or more of reduction on work and study. But on the other hand, if you can take a look at on the right-hand side, online or e-commerce usage increased sharply. So I guess that mobility was a little bit compensated by electronics, digital communication. But when it comes to shopping activity decreased, but somehow compensated by the use of e-commerce, but not to a full extent. As for leisure and sightseeing, there's a sharp decrease. And even online e-commerce couldn't compensate for the loss of those mobilities. That's the picture we see. So in short, when needed, people still move, but if possible, people will try to use online or e-commerce type of things. That's the picture we see.
Thank you. And this is clearly a big change, but it's also changing life, but also businesses. How do you think about it from the automotive area?
Okay. As we see in the previous chart, people will go to more on online and e-commerce. It means that they will use more computer and digital infrastructure. Computer and server include lots of semiconductors. Very strangely enough, the profit of automotive companies increasing during the period of the COVID because supply of semiconductors have been limited. So demand for automotive products is bigger than the supply. Very frankly speaking, today's Nissan lineup is very rich, but we can sell more. But the problem is we cannot produce more. More or less, every auto company has the same thing. So strangely enough, because of the COVID, we couldn't sell more, but we could earn more profit. That's the first implication of COVID-19. Then when we look at the people, maybe we should not look at the people as a whole. Maybe we should need some segmentation of people and lifestyle. Maybe you can show some slide. This is data from Japan. And if we divide the mobility between urban mobility and suburban mobility, and mobility on weekdays and weekend, the red portion is carried out by automotive mobility. And by far, automotive is has the largest share in most of the segment, whether urban area or suburban area or weekday or weekend. Of course, in the suburban area, because public transportation is less available, automotive sector is carrying out majority of the mobility. And if you look at the age and mobility on the graph on the right-hand side, say 20 or 30 years ago, younger people used to go out more, and older people stayed home more. But if you look at today's graph with the red line, young people go out less, and older people go out more. So somehow leveling is starting. So we really should consider the need of older generation as well as younger generation. Then mobility, there are many types of mobility, from vehicle to airplane to railway to ships to carry goods and people. And modern society needs various types of mobilities as a kind of essential condition to succeed. So what's the importance of mobility in terms of economic growth? As we see the growth in the GDP, we tend to see increase in traveling distance in each country, which is shown on the left-hand side chart. And likewise, if we see growth in the GDP per capita, then we will see a more number of owned vehicles, say in this case per 1,000 people. So as economic growth grows, traveling distance grows, and number of the vehicle will grow. So this is a kind of a general trend. I don't know which is the driver and which is the result, but important thing is that economic growth is somehow associated with the traveling distance and number of vehicles people own. If we apply this hypothesis, if economy grows and if we need more vehicles, what will happen in the future? This graph explains the population of each country on the horizontal axis, and on vertical axis is the number of cars owned by 1,000 people. For example, in USA has about 300 million people, or 0.3 billion people on the horizontal axis, and the height, it means that 800 vehicles are owned by 1,000 people. So if non-owners, which is shaded in the gray color, try to have the same level of ownership of the personally owned vehicles, we will have 6.3 billion vehicles globally. Today's number is 1.5 billion. Obviously, this is not sustainable from an environment, energy, and the resources point of view. So what shall we do? That's where we are.
And so if we think about mobility, there are maybe three major evolutions. We will talk about autonomous driving, electrical vehicles or EV, and of course the connectivity, vehicles to vehicles, vehicles to infrastructures. What do you think is the biggest impact to people?
I think that all technologies are necessary, first of all, but because if you consider global warming and the CO2 and energy and resources, electrification is a must.
Yes.
It's an entry ticket to the future mobility. It's an expensive entry ticket, but it will not change the life of the people in general. Connectivity is given. Everything must be connected. Everything must be digitized. So not only vehicle, but also the entire world needs to be connected. So from the viewpoint of changing the lives of people, I think autonomous technology is the most influential. That's my take.
Yeah, it will definitively change behaviors.
Yeah.
And services and utility.
Yes, indeed. For example, this is today's product. The name of the product is ProPilot. in Nissan terminology, and we have introduced ProPilot Generation 1 in 2016, and we have sold more than 2 million sets so far with zero accident, by the way. And ProPilot 2.0 released in 2019, which has much higher capability compared to the first generation. You can hands off the steering wheel, and it has a high definition map, and it has a driver monitor, and it's a redundant system, redundant ECU, redundant braking, redundant electrical communication. So it's much more performant, but a little bit more expensive. So what's good about autonomous driving, like a ProPilot 2.0? First of all, if you look at the left-hand side of the chart, this is a comparison of the lane centering accuracy. The blue line shows the result of a machine, how ProPilot can control the lateral positioning relative to the lane. And yellowish line shows result of a human driver. In this case, it's not the typical human driver. It's our internal, what we call A-class driver, one of the best driver.
Oh, wow. I thought it was like a drunk.
No, it's not. It's not a drunken driver or average driver. It's a professional, highly trained, highly skilled, certified driver. But even comparing one of the best drivers on the street and machine is much better already.
Wow.
Then how does it help? If you look at on the right-hand side, it's a measurement of the fatigue or stress, physical fatigue and mental fatigue. And from a tension of the muscle point of view, ProPilot 2.0 reduced 70% of the muscle fatigue, and mental fatigue is reduced by 90%. And we believe that this will ease the driving burden, but also indirectly contribute to the safety of driving.
And I think we'll talk a lot about safety. But when we talk about autonomous driving, my colleagues at TDK shared with me a really cool advertisement from Nissan that's in Japan. And even though I don't understand Japanese, I get the point about the advert.
Okay.
Do you mind showing it to us?
Please go ahead and share it with the audience.
自動運転の実現なんて夢のまた夢だって思ってる
He's a very famous actor in Japan.
信じられる何度でも何度でも自動で危険を回避するほらもう夢じゃない
He says that autonomous driving is not just a dream. Maybe, I'm sure you have missed key points, so let me explain a little bit. First of all, this prototype car is real, and this maneuvering of an emergency situation is real, not computer graphics or anything. So today, this vehicle has that capability. That's the first point. Second point is that you may have noticed that the vehicle applied braking or steering, depending on the situation. Yep. And also, it's based on the prediction of the move of the objects on the road. So if it judges that it's too late to brake and stop the vehicle, not to hit the object, it uses steering, or both braking and steering. Yep. So it's not just a reaction to the detected objects, it's planning. Trajectory of the object and trajectory of the ego vehicle to control the vehicle. And the third point, which is not the main point, but probably you saw the steering wheel was rotating. Maybe you can play the video again if you want. But actually, this vehicle is equipped with steer-by-wire. So technically, we don't have to rotate the steering wheel in order to steer the tires. See?
It doesn't need to do.
It doesn't need to do. But you may not know that Nissan has already introduced steer-by-wire like more than 10 years ago. And there's no problem in the market. But in the age of autonomous driving, if the system started rotating the steering wheel too quick, and if you put hands in the steering wheel, your bone will be broken. So this is not so well noticed, but a very important technology as well.
I think there will be a lot of challenge around user experience,
Yes.
UX. But I do like the fact you decouple the braking from the steering. Because if you were just braking, you may actually have problems.
Exactly. You know the point. Yes.
Yeah. Very good. It's very impressive about how it was avoiding all the accidents. And it was not at low speed. You could see that the veering was quite fast.
Yes.
So really the key message is about autonomous driving is not a dream anymore. And you mentioned it's a real car. So is it real now?
Yeah, I think it's not just a dream, but we still need a lot of things to do to realize it. So maybe you can show the roadmap of Nissan. The horizontal axis means traffic environment, if it's simple or complex or highly complex. Vertical axis shows the difficulty of maneuvering, normal maneuvering or emergency maneuvering. And for the generation of ProPilot and ProPilot 2.0, the system is operating in the zone of normal maneuver. So our effort, which is shown in the TV commercial, is a jump from normal maneuvering to emergency maneuvering. And once we master this jumping of the dynamic capability, we can extend more and more difficult traffic situation. Then we can enrich the performance of the passenger vehicle. Maybe we can apply to robo vehicle in a limited service area, but eventually maybe we can implement autonomous driving function in mass production vehicle. That's our roadmap.
And if we go back to the slide, I can see a robo vehicle. So clearly you have different granularity in your roadmap.
Yes.
How is that different in terms of highly complex situations?
In a highly complex situations, the factors that we have to consider is exponentially long-tailed use cases.
Yes.
So it will become more and more difficult and time-consuming. Initially, it's easier. As you go further, it will take more time. Yeah. So we need a different methodology to master autonomous level to robo vehicle. Yeah. That's our understanding. So in a real world traffic situation, there are many simple scenarios on the daily basis. Pedestrian is crossing the pedestrian walk, and even today's AEB or automated emergency braking system can take care of this kind of situation very easily. In a little bit more complicated scenario, pedestrian may come out behind the parked vehicle. In this case, autonomous vehicle needs a better imagination, because if it finds the pedestrian jumping out on the way, suddenly it may be too late. So the vehicle must be very careful not to encounter this kind of situation. So the one strategy is to drive slowly. But if you drive too slowly, vehicles in the back will start honking you.
Yes.
Then maybe you can master this. But if we go to highly complex scenario, okay, the vehicle is anticipating the risk of a pedestrian coming out from the parked vehicle, but at the same time, if the motorcycle is changing the lane to avoid other vehicle and may come in the same spot, so what will you do? So this graph is not so accurate, because a highly complex scenario has a long tail. And in order to master small number of long tail scenarios, we need an enormous amount of try and error. That's how we see the difficulty of realizing 100% safety.
In a way, this last, let's say, 1% is probably even more challenging than solving the first 99%.
Exactly. Because we are talking about, one fatal accident out of every 237 million kilometers on average in Japanese case. This number changes depending on the country. Yeah. So unless we can take care of this kind of a very rare fatal accident, we cannot say we master the safety of autonomous driving. That's the difficulty.
I think there is one word you use which I really liked, because you could have said you need to predict what could happen.
Yes.
But you use the word imagination,
Yes.
which is nearly like imagining what could happen, which may not even be in the data
Yes.
that has been training the model.
Right. Exactly. Probably that's the next discussion, I would say. By the way, this is a kind of the scene of how we test this kind of a scenario in our proving ground in Opama. The preceding vehicle avoided the tire coming, rolling tire coming out, but then other vehicle jumped in on the way. This looks very slow, but if you have a test ride, it's really scary, by the way. And this is how a machine is looking at the environment and deciding the path. So this is a record from different viewing angle. We invited motor journalists to ride this test vehicle, and they said that they couldn't avoid the second obstacle. Yeah, so it looks easy, but actually not so easy.
Okay.
Okay, but in order to achieve this kind of safety performance, we have to pay attention to both sensing performance and recognition performance. And you may think that okay, today we have lots of sensors, all are good. But human eyes combined with brain is quite capable, in our opinion. Human brain, there are several ways to see it, but human eyes has like a 7 megapixel in the center, and horizontal view 180 degrees and vertical 125, and it's three-dimensionally recognizable. But the camera used for our ADAS or Advanced Driver Assistance System has at most 8 megapixel right now. And the viewing angle is narrower, and it's basically 2D unless we have stereo camera. So, and also dynamic range in terms of illumination or darkness is much poorer on a camera. So we cannot completely compete against human eyes capability yet. On the brain side, even if you can pass, say 1 inch apart from the parked vehicle, if the door is open, at the end. So human brain always anticipate potential risk of other road users and find the best routing. And this kind of intelligence is essential. Next page, please. So that's why we are working with a sensor fusion of camera, radar, and LiDAR. And each type of sensor have different pros and cons. And there are many ways to approach how to use the sensors, but our belief is that it makes sense only if autonomous driving can drive more safely than human. In that sense, we think that combination of LiDAR, radar, and camera will be the fastest way to achieve our goal. As for perception technology, why is it so difficult when we have a neural network and the big supercomputer and so forth? But if you look at the example of traffic signals, each country has different type of traffic signs. But the key point, even Japanese cannot immediately understand this. Which rule applies to my vehicle? Because it says from 7 to 9, it's straight, 16 to 18 hours straight, but except large vehicle. So is my vehicle large enough to follow this? So at a glance, it's simply impossible. But artificial intelligence should be able to immediately understand this. So if we apply this kind of technology well enough, probably we can have much safer artificial driver on board. But we have to master this.
I have a question about this slide, which also shows the US and Japan and probably other countries. Your neural network needs to be trained on a country-specific. Now, some cars, of course, will cross countries, but some will not. So if it's in Japan, it's unlikely to go somewhere else. So how do you train the model to be really good at where it's going to be used?
I guess that there are some commonalities regardless of the regions. For example, how to brake a vehicle, because we know the friction of a tire, what kind of a road surface, what's the weight of the vehicle, what's the gravity of the center, and what's the stability. We can master that. Probably that part is not so different region by region. But when it comes to traffic sign, probably we need a different set of algorithm.
Yeah.
I'm not expert of artificial intelligence, but I hope that someday we can have some kind of a better algorithm why human drivers can easily get accustomed to driving in France and the US and Japan relatively easily.
Yeah.
When I first drove in Paris, I was really scared how people...
It is scary.
It is scary. But after 3 days, I didn't have much problem.
You became Parisian.
Parisian, yeah. So, but we don't have that kind of technology. How we can utilize already learned part of algorithm and apply it to different environment. I think we have not mastered how to do it. Maybe human brain has a different type of algorithm. Expects that technology that you are promoting could solve this kind of agenda as well.
I think it's a combination of two words you use, imagination and intuition.
Mm-hmm. Yes.
And I think that's why when you talk about autonomous driving, you use these words too, because we hope and we wish to have autonomous driving being like a human brain.
Mm-hmm. Yes, exactly.
So when we talk about DX, we should be thinking about a mobility platform.
Yes.
And it's not just infrastructures, the vehicles, there's even UX involved.
Yes.
How do you think it will transform ourselves?
Yes, I think digital transformation will have a huge impact on the transportation of many kinds of people. But I think it's important to look at people and region in a different manner depending on the customer need. We cannot say people as a whole.
Yes.
So let's look at some examples.
We need granularity.
Granularity, yeah. People are different, or kind of same on the other hand. This is a global trend of urbanization. More and more people will live in an urban area rather than suburban area. So there will be a concentration population in urban area, which means that the people will live in a high building and public transportation may be more available. And as we see in China, it's impossible to accommodate all the requests to own the vehicle. So we have to limit the issuance of license plate and so forth. So urbanization will impose a very severe restriction on the usage of privately owned vehicles. Next slide, please. The other social trend is aging. So far, Japan is by far the most advanced country in terms of aging, and Korea and China will have sooner or later the same trend. So we have to consider this because aged generation of a customer have a different requirement, which is explained in the next page. First of all, the eyesight becomes poorer, and the visual angle will be poorer, and then we start seeing the traffic accident in a cross-traffic situation. So maneuverability of the vehicle will be deteriorated. Now, as a result, we see a steady trend that the number of traffic accidents caused by a driver at the age of 65 or more is increasing. So we cannot simply accommodate aged drivers' request to continue driving at the scale. Okay. So in order to respond to different need of region or segmented population, we are conducting two kinds of a field operational test in urban area in Yokohama and suburban area in Namie in Fukushima prefecture. The Namie township was heavily impacted by earthquake and tsunami and a nuclear accident, just for your information. On the urban area, we are targeting business people and sightseers and so on, and we put an emphasis on how convenient it is to call the vehicle and cover the most interested area in the town of Yokohama.
With very little waiting time.
Right, of course. If we make customers wait for more than 1 minute, they will cancel the request. They are very impatient. That's one of the lessons we had. In this case, it's autonomous vehicle. There's a safety driver on board, but he or she is not driving a car. On the suburban side, we implemented a local traffic system with the driver, because the objective is not to test autonomous technology, but to try to build the ecosystem of mobility. In this case, we targeted local residents and also visiting passengers, and we combined delivery of goods in partnership Aeon, which is a major supermarket, and a postal service company. So the idea is to combine mobility of people and goods and post delivery packages.
I think it's a really good way of describing mobility service. It's not just a car, it's a full ecosystem, it's a full solution.
Yes, yes, indeed. And also, I didn't mention, but this integrates the usage of renewable energy. So it's total small scale smart city or smart village to take care of all aspects of mobility of people, goods, and taking care of energy.
Yeah. So do you think all the automotives will become embracing this mobility service in the future?
Rationally, yes, but personally, no.
Oh.
I entered Nissan because I love cars. So I believe that automobile has two aspects. One is a tool to move people and goods. For that, we need social responsibility, how to solve environmental issue, energy issue, resources issue. The other aspect is more like experience, emotional experience associated with driving a car, like a sports car, or moving to some interesting place with family, or visiting your friends or whoever. So the combination of rational value as a tool of mobility and emotional attachment of a customer, I think that's why we think that automobile is interesting. That's my view, or just my hope, to maintain attractive side of the value of the vehicle.
Yeah. In a way, the left side is a rational, the mind, and the right side is a heart,
yes,
the emotions.
Exactly.
Yeah.
Yes.
And so I just want to show to the audience, on the left side, the bottom part with the drawing is actually the sustainability aspect with the energy that's renewable, probably some long duration storage, and then the charging of the vehicles. How do you see the future of that ecosystem? Is that something that's village by village? Do you see it as a blueprint for the future?
I don't have that clear answer yet. The agenda is clear. We don't want to waste any energy. We want to avoid all traffic accidents.
Yep.
And still we have to offer flexibility of transportation. You can go anywhere, anytime. But the need of the customer will be very different, because some people may be not interested in driving a car at all. All they want is to move from point A to point B. In that case, mobility service will be a perfect fit.
Pure utility.
Pure utility. But some people love cars. They want to own cars. They want to kind of maintain cars and modify cars and keep 10 sports car in the garage. We cannot deny that. In that case, maybe we need to offer both personal mobility, still driven by human driver, but with much safety capability behind the wheel.
Yep.
So that's how I see the future of mobility. So I don't know the answer, but we are preparing pieces to answer your question.
And I really like it because you're addressing both the mind and the heart.
Yes. At last, maybe we can see.
Yeah, I think we have time for showing this video, which is really nice. It's about the pleasure of driving.
Pleasure side of the driving, yes.
nice. So I might already know the answer, but out of the 6 final cars, which one would be your preferred?
This is not official comment, but I prefer that the convertible. But that's a really serious design, by the way.
Yeah.
Yeah, it's not just a kind of a shape. We calculated the aerodynamics and so forth, and can we fit the electric motor inside? So it's kind of a fake, but inside is not fake.
Very nice. Yeah. And not surprising answer.
Okay.
Very good. I like also, I mean, we talked about village and we talk about ecosystem, but you also have the word community coming through this.
Yes, right.
And I see how you're trying to integrate people into the mobility platform.
Yes.
If I was to ask you before we turn to the audience, what do you think is the biggest challenge to serve community when you think about mobility?
I think, as I commented, communities are not the same. And depending on the area and the population, the needs is completely different. So one idea is to start small, just like a Yokohama or Namie. What we don't know is if this kind of business model or technology model or ecosystem is compatible when it comes to expansion to other regions.
I see.
But if we start big, we cannot achieve anything.
Yeah.
So that's one of the most difficult point that I see. But we know the goal because vehicles will be accident-free, and vehicles will be CO2-free, and it will be recyclable.
Yep.
So if we have no negative points, then it depends on our imagination how we build the new mobility system for the need of each community. But inside the community, there are different people. So to what extent we have to divide our solution. But I hope that there will be infinite number of combinations rather than finite combination rather than infinite combinations. Sorry, I cannot satisfy your.
No, I think it's actually a very good answer in the way where you're describing experimentation.
Yes.
You're going to try, see if it works, and then see if it can replicate. And I think that's actually the right approach. We don't have all the answers.
Yeah. That's how we are approaching the future mobility.
Very nice. So I received already one question from James. Fantastic technology. So I think you've already convinced someone already. Thank you, Nissan, for sharing. And I think there are 2 questions. Do you foresee potential for the technology to accelerate or be delivered sooner than expected, given the amount of investment being seen at AI and machine vision?
Yes, for the first question, to accelerate the delivery type of application. First, driverless mobility has different type of issues, problems that we have to solve. For example, who will clean the vehicle? Not me.
Yep.
Who else? And if you forget your bag inside the car, who will try to find it?
Yeah, no more driver.
Can you go after the vehicle that you already got off? So, and delivery may be possible, but if the destination is hidden in a gateway, can you push the intercom, or how do you do? If customer forget about the order delivery, how you handle it? So probably the bottleneck is not only technical part, but also how we handle this entire logistics without human being involvement. I'm concerned that part. Even robotaxi, okay, if you call robotaxi, there are robotaxis running around in the future. So which robotaxi did you call? We're already facing this problem. That's why we show the QR code and make sure that it matches the vehicle that you ordered. But if there are many, how do you handle it?
Yes.
In today's ride hailing, it's here. Yes, I'm driving a red sedan, and such communication is possible with the human driver. but without a driver, how we can handle it? That's very, very interesting problem to solve.
I think the intercom example is so interesting because we have designed the world assuming there is a driver.
Yes.
Even going to a parking space, the driver is
Yes.
the one taking the ticket.
Right. Yes.
But we have to redesign that.
Right.
Okay, very interesting.
Yeah. And also, I think the second question about usage of AI or that type of
Machine
technology.
vision.
Yes. And personally, I'm highly interested on the evolution of AI technology because this is my personal view. Something is wrong with today's neural network type approach. It takes too much time to train the network, and it consumes huge electricity.
Yes.
So when we are building the vehicle, first thing we have to consider is, okay, how to cool the CPU. And the computer is big, and we need like a water cooling system and so forth. But we don't consume that type of a heat in our brain yet. So something is wrong. And also how to guarantee safety of the vehicle must be explained by automotive company in front of the authority, legal authority.
Yep.
And if we cannot extract logic out of a neural network, we cannot do that.
Yeah.
That's a huge challenge, and I'm not the expert on an AI, so I just hope that someone will help us to solve that problem.
In a way, moving from a brute force approach to an elegant approach. Yeah. And there was a second element to the question from James, which was, and I think it's interesting because here you have to predict the future. Do you foresee passengers car or buses or trucks being autonomous first?
I think it's not a technical issue, rather it's more like business needs. Because I understand that in Japan and in the US, maybe same thing, drivers are lacking long distance truck industry, for example. And so probably sooner or later, we need more drivers, which don't exist. So business need seems to come first. But technically, trucks are easier to automate because large trucks routing is a little bit more fixed compared to passenger vehicles. And also, from vehicle control point of view, all it can do is braking. Sharp steering is not an option. If you see a 16-wheel trailer, you cannot
Yes.
you cannot change lane that fast as the skyline that we saw in the video. So controllability is so limited. So control of the vehicle is easier because there's not much option to find the risk as soon as possible and apply brakes. That's the strategy.
Yep.
And if the road is easier, maybe large truck or logistics trucks seems to be easier.
Yep.
But again, I think it's more like a business-driven in my view.
I'd like to think that the autonomous driving on a truck would be so much more responsive than a truck driver that's been driving for 5 hours. So
Yes.
we would be tired. And
Yep.
Yeah.
Yes.
I would like to ask a question in person.
Thank you very much for interesting talk. I'm Ishiguro from TDK. Just I have one question that in Japan, just the Golden Week was over, unfortunately. But every long weekend or long vacation time, that the TV program always, TV news show is always indicating the long queue of the long traffic jam. Do you believe that we will be able to reduce such a kind of traffic jam in the future by autonomous driving?
Ishiguro-san, thank you for the question. I think it's partly yes and partly no. Because if we use the full capability of an autonomous vehicle, we can reduce the distance between vehicles. And it's really scary, but even 1 meter is long enough. It's really scary, but please don't worry, it's safe. So in that case, we can shrink the length of the school of vehicles on highway and even local road. But if everyone goes on the road, maybe absolute density of the vehicle may be too high to manage, even if we apply the best technology. So maybe partly yes, partly no means that technically we can reduce, but I'm not sure if we can totally resolve this traffic jam.
Very interesting story. Thank you very much.
Thank you.
Thank you. We have one online.
Yes.
Oh, this is quite provocative.
Yes.
Do you think the number of OEMs will increase or decrease in the future?
Okay.
Within the automotive mobility and autonomous driving?
I think it's a good question. I don't have the correct answer yet. But one factor we have to consider is that if we go to mobility service more, meaning we will see less number of vehicles personally owned because of the urbanization and aging society, clearly number of vehicles that the automotive manufacturers will produce will be much reduced.
Yeah.
So can we maintain the same number of automotive manufacturers as today? I doubt that. But on the other hand, traveling distance could be even more. So if we start making money out of mileage, not selling new vehicles, probably business still exists. But the question is, who are they to do that service? If you call it automotive company, maybe. But if it's a different player, we don't need automotive company. That's my view.
In a way, do you think there's an advantage for the car OEM to deliver more services around the car than a pure service company that actually doesn't control the car itself?
I think it's a very good strategic discussion. Even today, we make large part of the profit in after sales, sales finance, and maintenance. In addition to sales of new vehicles. So if you look at the proportion of profit of selling new car and after sales, you'll be surprised. So in that sense, we are already service company.
You are.
We are. Yeah. And new car is a kind of tool to get a profit.
A tool or a Trojan horse?
Yes, maybe Trojan horse. Yes. To bring that kind of the services. But who will be the best fit to providing the mobility service is something I have to think about. Because you can drive or get on the car and say 2 hours a day at most, maybe 3 hours, depending on the person. But for the rest of the day, you are with your smartphone. So which is controlling your life, personal life on a daily basis? Probably it's more like IT digital world, not automotive world.
Yes.
But value judgment may be different. Because as I said, the consumption of mobility is not necessarily rational. Sometimes irrational.
Yeah.
People want to buy a sports car that you don't use. People want to have a big SUV that you don't use. Or you use it, but not for that purpose.
Yeah.
So what's the value of buying and using a car is not necessarily pure economical or rational. So in that case, maybe traditional automakers may have some chance to combine this emotional value and services. But again, I don't have a good answer for that.
And I think car makers like Nissan have been very, very good on the emotional side, but there's so much learning on the pure utility, which probably create disruption opportunities, which could be incumbents, which could be new players.
Yes.
Very, very nice. I have one more question from Aniket. What do you think with realization of dynamic switching in situation in autonomous driving? What impact it would make on passenger vehicle sales or other automotive segments?
I'm sorry if I understood the question right. So it's just kind of switching the mode or?
Dynamic switching in situation of autonomous driving, which I think touched a little of our conversation we had before today about user experience and human expectations of what the vehicle should do versus not do.
Even today's vehicle, there's different level of automation. I think that nowadays you don't drive a manual shift too much anymore.
Not too many, no.
Not too many vehicles, but some enthusiasts prefer a manual gearbox. Then there's a speed control. Now it's a adaptive speed control. Then ProPilot comes in. So to me, it's not a switch on and off. Automation already started from many years ago. So eventually, full automation should be available, depending on your need. If you're tired, or you want to work, maybe you shouldn't drive. But if you want to enjoy driving on a very nice winding road in a suburban area, maybe you want to forget about work and so on, then you may want to drive manually. But again, it's backed up by the safety system. So it's much safer, secure than you drive alone. So to me, it's not the kind of a total switch on and off. It's always on behind the scene.
Like an angel behind you.
Yeah. And there's a guardian that you don't make a fatal mistake. So it will be a different type of vehicle from the past. But still, you can enjoy rational usage and emotional usage. That's my feeling.
Thank you. I have one more question from Paul. And we didn't talk so much about levels of autonomous, but this is one about it.
Yes.
What do you see as the greatest challenge to bring mass volume level 4, level 5 autonomous driving from a technology, resources, acceptance, and legislation? And what time frame can you expect?
Yeah, I think the critical point is safety, as I commented. Because if it's autonomous driving, or highly automated system for general customers, they can go anywhere. And then we will face this long tail type of complicated scenario. And we cannot say, oh, we didn't consider this. Then we should have told them not to use this system in this area.
Yes.
Or limit the usage. But unless we know the long tail situation, we cannot do that. So to me, it's more like how we can provide safety of big population which can go anywhere. That's the biggest challenge to me. But of course, in order to do that, we need lots of resources of simulation and testing and field operational test. And also, in order to guarantee highly safe system, maybe the cost of sensors, the cost of computer, and cost of cloud maintenance and so on will be expensive. But if we decide to do so, I think we can. But it will take some time. Then that's why we started introduction of ProPilot from highway. Highway is much easier.
Predictable.
Predictable, then extend the use case to a kind of relatively easy road, then go to more difficult road. So we are taking this kind of very practical approach to expand the use cases.
And you mentioned earlier, there's not so many accidents per millions, 268 million miles driven. So it's not like the database you're building has so many cases of accidents.
Right.
So how can you make sure that you have safety for things you cannot predict and you don't have data for?
Right. Yeah, I think it's a good point. So of course we are analyzing each one of those accidents. What happened in reality? So we send people to the accident site and analyze everything to reconstruct what kind of parameters were there, what's the speed of vehicle, what kind of judgment the driver did, and what's the impact. Then we start modeling of the accidents. Then we change the parameter. If the speed is higher, what happened? If the driver noticed the risk sooner, what happened? So based on the facts, we need to model it, then conduct simulations as much as possible. But simulation includes not only sensing performance, but also vehicle dynamics. Because even if the system orders vehicle to stop, it cannot stop in 1 meter.
Yeah. Especially if it's rainy or
rainy
snowy.
and snow and variation of braking performance because of the aging of the brake pad and so on. We have to consider all those type of things. It's big job to master it. And I think our friends in the industry, I think we are facing the same thing.
Actually, maybe it's a naive question, but do you also simulate the quality of the tires and how new or old they are? And
yes, of course, because we have to consider all variations. And if tire has no remaining the grip, we have to warn the driver, you cannot use this tire anymore.
Yeah.
It will not provide the braking performance it was designed on. Even today's system already says that if it's raining too hard and if the image of the camera is blocked, it says it's raining too much.
Yeah.
System is not tentatively unavailable. Kind of thing will come up. So that's a must.
Very nice. I have one more question, which is again about regulation. So first, it's thank you for your time today.
Yes.
Would regulation be the biggest bottleneck for full self-driving to materialize?
I don't necessarily think so, because exact regulation doesn't exist. Regulation assumes just a kind of framework. In order to test this vehicle, you have to put a safety driver. You have to be careful on this, but there's no concrete methodology. You have to clear these test use cases by this methodology. This kind of a protocol is not defined. So it's kind of vague because no one knows how to do it. Yeah. So to me, it's more like an interaction between regulators and automotive companies and other players. Iteratively.
Okay.
Yeah.
Actually, we've seen regulators being more open-minded than I think we would have expected.
I think so. Yeah.
They do want the reduction of accidents.
Yes, right.
They do see an opportunity there.
Yes, I think we share the same objective. Yeah. And we are collaborating, of course.
Yeah. So the question from Bowler continues with, when do you think full self-driving robot taxis, the utility element you mentioned, become a reality? And of course, the question is, and would this bring cannibalization risk to the automotive industry?
I think this robot vehicle is already a reality because we are talking about level 4. Level 4 means that in a given condition, it operates without driver. By removing impossible use cases, it's possible. Like a company like Waymo or Cruise or Pony AI or WeRide, and those companies are working on it. But it's possible. Okay, let's choose San Francisco only, then we can master it. Yeah. Let's remove snowy day. Let's remove some special day. Then we can narrow down the use cases to the extent that technology can meet. Yep. Then the question is, can they make money out of it? I think, can you make money? Can technology support it? Then can you make money? I think each player is working on it. But level 4 based robo vehicle is a reality to that extent. But if it's level 5, it's still a long way to go. Yeah. I think.
I think the level 4 is really about, for certain conditions, you can really be autonomous.
Yes.
Like you said, there are many cities where it's always sunny. That's easier to have a robot taxi. Yep. If you go into places where it can rain and snow, this is very different.
Yep. Yep.
Very nice. So I want to take one more questions. So one from Sachiko. Thank you for the insightful talk. With more time and the freedom of mind in the automated car, so let's assume level 4 for now, how do you think the cabin experience will change? And how can car OEM differentiate themselves by that user experience?
I think if we achieve level 5, level 4 kind of autonomy, it will be the same as living room. So there's no differentiation because room is just moving. But in order to achieve the statement that it's the same as a room, we are working on it. First, we have to achieve a very quiet interior.
Yeah.
Today, there's a noise from the tire and so forth. And when the vehicle brakes, there's a kind of a...
You feel it.
You feel it and nose dive. And when making curve, there's a gravity towards the outer side of the curve. So we are trying to control that so that the vehicle is optimized like a bullet train. When a bullet train makes a curve, there's a kind of a compensation of the gravity so that the gravity is always vertical to your body. This kind of technology will be a differentiator. If we think that we can provide a unique experience based on autonomous driving. So combination of the autonomous driving technology and vehicle control technology and dynamic performance related technologies such as noise, vibration, and harshness, we should be able to master it. And it's a kind of a traditional technology, but lots of creative thinking is necessary.
I like to say it's a golden nugget because there are so many technology yet to be invented for this type of experience to become a reality.
Yes.
And you haven't said it, but some people get very easily sick if they don't watch the road.
Right.
But if the expectation is that you're in a room and you don't even look at the road,
Right. Yep.
you need to change quite a number of things
Yes.
for it to become comfortable.
Yep. Exactly.
So I want to finish with maybe one question, which is really looking at the future. What are you most excited in the next 5 years in terms of mobility, but from an innovation point of view?
Mm-hmm.
What is the innovation you look forward to the most?
Okay, aside from today's main topics like the digital side, I still feel that today's automobiles have negative side of like accident and energy and resources and traffic congestion. And those negative sides should be resolved. And I expect lots of innovation still happening for the epoch-making battery to some kind of recycling technology.
We are working on it.
Okay. So there's a massive expectation on this innovation to resolve this negative side. But still, I still want to offer the pleasure of using or driving a vehicle as a tool to enjoy emotional experience, customized to each customer's different need. That's my dream.
And that's a dream of guilt-free pleasure.
Yes, exactly.
Thank you so much, Asami-san.
Thank you.
That was really, really nice. Thank you.
Thank you.